Hey peeps, today's lesson is solving equations with variables on both sides. So we can have x show up multiple times in an equation, but that's really not a problem. I'll give you guys a nice little method to solve those. All right, so a term, first thing we need to discuss, and hopefully this is a little bit of review, is a number, variable, or combination of numbers and variables multiplied together. So kind of the follow-up idea here is terms are separated by addition and subtraction. So with the exception of parentheses in problems, when there's parentheses, the parentheses are part of the whole bigger term. With the exception of that, addition and subtraction signs are what tell you that two things are separate terms. So we'll do a quick example where we identify how many terms are in a few different expressions. So here's a few expressions for us to look at. So number of terms. Terms are separated by addition or subtraction. 10 is a term. 4x is a term. The minus sign is what tells us those are separate. In the second one here, so that's two terms. In the second one here, 15p squared, that is numbers and variables multiplied together, that is one term. Looking over here, we see a minus sign inside the parentheses, but this is that exception I was talking about. Because the 2 is multiplied by the whole parentheses, we treat the whole parentheses like one thing. So this is a term on its own. This plus sign, though, does separate. So this is still something I would consider two terms. Now what's kind of weird about this is even though it's two terms, if I choose to do the distributive property and get 2x squared minus 8 plus 1, now I'm going to call it three terms. Well, heck, now if I combine like terms with the minus 8 and the plus 1, it'd be 2x squared minus 7. And now it'd be back to two terms. So it's very malleable. We can switch stuff around a lot. But in the big picture, what I have written down right here is just two terms. So without messing stuff around, I would consider this whole thing one term as far as the math we do later. All right, and this last one, just 0. 0 is a number. Sometimes we just look at 0 and get confused because it's like, well, that doesn't stand for anything. Well, it is a number, so it is a term. All right, so hopefully that gives you a few ideas of the cases we would deal with when we're talking terms. And that vocabulary is going to be a little important because it'll help us figure out some of our algebra steps later. Here's a little more vocab for us. Constant is going to be a word you hear all the time, constantly, in math. And it's always talking about terms with no variable part. So 2.3 is a constant. 0 is a constant. Any negative number like -3 would be a constant as long as it does not have a variable with it. All right, and then like terms are two terms that have the exact same variable part. So it does not matter what the number piece is, the coefficient's the number in front. 3x and -6x would be like terms. That works. All right, but now if I do something like 2x squared, that is not like terms with those other two. Because the x is x squared, that's not exactly the same as x. It does mean exact same variable part. Now if we want to get really messy, we can start introducing multiple variables. So I can have, like a 4xy and a 3x squared y. Those are not the same, because the x has a squared in this one. If I get rid of that, though, we're good. xy and xy. We're not going to spend a whole lot of time looking at stuff like this year. Maybe a little bit when we're factoring expressions, but I wouldn't worry too much about that case. It is good to know that they're like terms, though. This is just a quick little example, and all I'm asking you to do here is circle, box, underline anything that's like terms. So I'm going to start by boxing in this 3x squared and look for anything else that's a like term. So I'm not really looking for numbers, I'm looking for an x squared. So if I scan over, 4x squared matches, I should give that a box. All right, now I'm going to circle 5x. Anything else that just has an x, if I scan over, negative 2x. And here's something I do kind of want to point out for you. I circled the negative here, but not the plus here. I could have circled that plus sign. But basically what I'm showing you here is whatever symbol's in front of a term is paired with it. So this is a positive 5x. This is a negative 2x. So this is plus, this is minus. This is positive, this is negative. You know, it's a simple idea to me, but it's a mistake that I see students make a lot. And last thing is I'll underline the minus 8, the negative 8, and the minus 12. Those are both constants. They have no variable part. And if they both have nothing, that's exactly the same, right? So those would also be like terms. So the next example is combining like terms. And when you combine like terms, the rule is add the numbers together, the coefficients, and leave the variable part alone. So combine like terms is a really common phrase we'll use. This is add coefficients of your like terms, but don't change variable part. So an x squared should stay an x squared. 5x and negative 2x should not make an x squared. It should just have an x. That part does not change. This might be a review for some of you. I hope it is. But I have a 3x squared and a 4x squared. I'm going to add the numbers in front. That's 3 plus 4 is 7. 7x squared. I've got a 5x and a minus 2x. 5 plus minus 2, or 5 minus 2, is 3. So that's just 3x. Again, the variable didn't change. And then minus 8 and minus 12 makes minus 20. And that would be my simplified expression. I will be doing a little more of that later, but just hopefully a refresher for you. Nice blank canvas here. I'm going to go through our general process for solving linear equations. The first thing I always want you to look for is any way to simplify each side. Now, what do I mean by simplify specifically here? There's two things we're really looking for. If you can use the distributive property anywhere, so if you have parentheses, this will get rid of the parentheses. It's a nice little tool. And then after the distributive property, check for like terms, combine like terms. Now when you do this combine like terms step, you do each side of the equation separately. All right, I would not combine something on one side of the equation with the other side. We have algebra steps, adding and subtracting, to deal with that. The second thing we're going to do is those adding and subtracting steps. The goal for this step is to get all of the variable pieces on one side and all of the number pieces on the other side. So add and subtract to get all variable terms on one side and all constants on the other. Now, if we've successfully done 1 and 2, step 3 should be pretty straightforward. Multiply or divide to get the variable alone. And then we're solved. So this little 3-step process might seem pretty straightforward. Distribute if you can, combine like terms. Then try and combine all of your variables on one side and constants on the other, and then multiply or divide. When we get to the actual math steps, it might look a little more complicated, but always just go back to this. You'll always have a starting point to look for if you follow a little strategy like this. So let's look at some examples. These have worked out solutions on page 20 of your textbook. Let's try and use our three-step process. So let's start with this equation over here. Step 1, we're looking for the distributive property. I don't see any parentheses, so that's not going to happen. And now I'm looking for combining like terms. This side does not have any like terms. 10 and minus 4x are not like terms. This side, well, there's only one term, so there can't be anything to combine. So step 1 over here, we're already cleaned up. There's nothing really to do. So we'll move on to step 2, which is try to get all the variables on the same side. Look for the easiest way to do this. All right, if I get my 4x over here, then the 10's already alone over here. So I'm thinking a little bit ahead into the future, but adding 4x, so the 4x moves to the right side, is the fastest way to do this. I could add 9x, but then I'd have to subtract 10 to the other side. So I'm just trying to choose what, in my mind, I think ahead and find to be the most efficient. So 10 is left over here because those cancel each other out. Negative 9x plus 4x add up to negative 5x. All right, so that's step 2 done. All my variables on one side, all my constants on the other. Now we just multiply or divide. In this situation, we got to divide because x was multiplied by that negative 5. Always do the opposite. 10 divided by negative 5 is negative 2, and we're happy. That was a nice short one. All right, the second problem, very clearly there is some distributive property to do. So I'm going to do both sides at the same time because all this is multiplying. 3 times 3x is 9x, minus 3 times 4 is 12, so minus 12. 1/4, little strategy for you guys, when you have to distribute a fraction like this, multiply by the top number, then divide by the bottom number. Really simple. 1 times 32 is 32. 32 divided by 4 is 8. 1 times 56 is 56. 56 divided by 4 is 14. Now, yes, I have decent mental math skills, but you can just whip out a calculator and do the same thing I just did in my head. All right. So, combining like terms, well, these are not like terms, so there's nothing to do there. Same thing on the right side. 8x and 14 are not like terms. So we had to distribute, but we did not have to combine like terms. Next goal is to get the variables all on the same side using our addition or subtraction steps. All right, so I'm going to subtract the 8x. Now here's a little thing I do that's just a preference. I like to keep what's in front of the x positive if it's convenient. So here, subtracting 9x would put a negative in front of that. I don't like negatives as much as I like positives. So I've got a 1x here, 9 minus 8. 1x can just be written as x though, because what's 1 times anything? Just that number. So we don't really need to leave the 1 there when it's just a 1. That minus 12 is still there, and there's still a 14 on the other side. Now I want to get that 12 away from the x, so I'm going to do plus 12. X equals 26. Now that seems like a kind of high number, but the next thing we're going to do is check our work, so we'll see if I did that right. So the more complicated these get, the more useful it's going to be to check your work. There's just more room for error, right? So I'm going to plug these numbers back in. So if I rewrite the equation but replace x with what I think x is, both sides should come out to the same number. Minus 4 times minus 2 is a positive 8. Negative 9 times negative 2 is a positive 18. 10 plus 8 is 18. That one checks out. Smiley face. How about over here? Gonna have to do some bigger multiplication because I got a bigger number sitting in front of me, but now I'm gonna do a little strategy over here. But this side, first off, 3 times 26 is 78, minus 4 is 74, times 3 is 222. Now I'm going to do my distributive property first, just like I did up here when I was solving. So it's going to be 8 times 26 plus 14. So 8 times 26, that's 160 plus 48, that's 208. 208 plus 14 is 222. So even though we got a bigger number, when we go back and check, it works out. So more happy face. That's just a quick way to check your work. I kind of like to give you ways to do that. Unfortunately, it makes you basically spend twice as much time on the problem, but in the future, there'll be quicker ways to check work on problems. The next little idea we're going to cover now that we have x showing up on multiple sides is we have the possibility for infinite solutions or no solution. So infinite solutions is going to happen when x doesn't matter and the equation always works. No solution is the exact opposite. X doesn't matter, but the equation never works. So with these linear equations, one thing I just want to point out for you is x will cancel out. When we try to add the variable parts over to match them up on the same side, they're just going to cancel out and they'll be gone. So that's why x doesn't matter, because in these situations, x has canceled out. We'll take a look at that right now. All right, here's two equations that are going to give us some of those special solutions. So we'll start with the left one. I'm going to do my distributive property, following my steps. All right, now I want the variables on the same side, so I'm going to subtract this 15x to try and get it over here. But when I do 15 minus 15, I get 0. 6 equals 0x. Well, what's 0 times anything, guys? That's just 0. So like I said, x is going to cancel out. But what's left over? Does 6 equal 0? Does that work? That is a no solution. If the variables cancel and what's left over is not equal, no solution is what we got to go with. Distribute over here, you get negative 8y minus 2 equals negative 8y minus 2. Interesting thing, these are exactly the same. All right, now I'm going to try and get the variables on the same side by adding 8y. Well, negative 8y plus 8y, negative 8 plus 8 is 0. What's 0 times anything? Again, just 0. That variable is going to cancel out. 0 minus 2 is just negative 2. Well, the variable canceled out, but this time it works. So in this situation, it does not matter. Oop, that wasn't supposed to be my answer. Infinite solutions. My answer should be infinite solutions. In this situation, x doesn't matter, but the equation will always work. So we could spend our entire lives searching for an x to plug in that doesn't work, and we would not be able to find one. Sorry, I guess it's a y for this equation, but same concept. We'll do the word problems together in class for this lesson because I think they're kind of neat, especially if you actually looked at the notes. The first one that has to do with the boat on the Mississippi River is kind of a, I mean, I like it. I'd call it fun, but yeah. Again, try and bring any questions you had from this video to class, and we'll spend all class practicing. Thanks, guys.